This LOS is explain measures of sample skewness and kurtosis. Kurtosis in return distributions. Kurtosis is the statistical measure that tells us when a distribution is more or less peaked than a normal distribution. A distribution that is more peaked than normal is called leptokurtic. Lepto from the Greek word for slender. A distribution that is less peaked than normal is called platykurtic. Platy from the Greek word for broad. And a distribution identical to the normal distribution in this respect is called mesokurtic. Meso from the Greek word for middle. The situation of more frequent extreme large surprises that we described is one of leptokurtosis. So you've got more frequent extremely large surprises. That's going to give you a distribution that is more peaked and more slender. Leptokurtosis. So let's just do a quick little practice problem to check your understanding. If a probability distribution is very similar to a normal distribution, then the kurtosis is best described as A, leptokurtic, B, mesokurtic, or C, platykurtic. Okay, that's a pretty easy practice question. The answer is B. Normal distributions are mesokurtic. Leptokurtic are more peaked, and platykurtic are less peaked than normal distributions. Here's just a graph to show you very quickly a distribution that is more peaked than the normal is called leptokurtic. So we can see the normal distribution, and then the dotted line, a fat tails distribution. It's taller and slender, so it's leptokurtic. So now we move on to kurtosis, and there's a little bit of memorization that you need to do here. So kurtosis for a normal distribution is 3.0. Excess kurtosis is kurtosis minus 3, okay, negative 3. Excess kurtosis is 0 for a normal distribution, because you can see 3 minus 3 equals 0. So excess kurtosis for a normal distribution is 0, okay? And excess kurtosis greater than 1 in absolute value is considered significant. So we're finishing this LOS with a practice question. Which of the following statements about a normal distribution is least accurate? A normal distribution A has an excess kurtosis of 3, B is completely described by 2 parameters, or C can be the linear combination of 2 or more normal random variables. Okay, the correct answer to this one is A, because that's the false. Remember, we're looking for the least accurate. Always underline that on the exam situation. A normal distribution has kurtosis of 3. It has excess kurtosis of 0. Okay? And B is true. A normal distribution is completely described by 2 parameters. That's some principles of a normal distribution. And also C is true. A normal distribution can be the linear combination of 2 or more normal random variables. So that's the last slide for this LOS. Thank you.